Okay, let's restart the session. The last talk is entitled Flexible Job Shop Scheduling for Semiconductor Manufacturing with Hybrid ASP. So the authors are not here due to some reason, I don't know. But instead, the session chair of previous session, the Professor Wolfgang Fieber will present this talk. Please start.
Thank you very much. Yes, so I can give you the reason why. It's so actually both Mohammed and Ramsha were supposed to come, but they didn't receive their visa in time. So they actually filed for it pretty early on and had both had an interview, but then they didn't receive it in time. So I'm not sure, maybe they received it today or something, but anyway. Yeah, so they asked me to do it, and yeah, I'll try to do my best. It's always interesting to present somebody else's work. I mean, we all work at the same department, so I'm vaguely familiar with what they're doing, but yeah, let's see. Maybe you can help me out if I don't understand things here, okay? Yeah, okay. So the topic is actually a little bit similar to what we heard earlier about scheduling maintenances. So this is one of the features that's going on here. However, the framework is a little bit different, I think. And so the problem that they address arises from an industrial partner that they are working with. I'm not sure whether you know, but the region of Carinthia, which is in southern Austria, actually is home to a couple of international semiconductor companies who have their manufacturing sites there as well. So they just recently opened a brand new factory, which I don't know, can deal with wafers of larger size than ever before. And but I don't know much about this. I just hear the news and relay that to you. So, however, these manufacturing processes for semiconductors, it seems that they involve a lot of machinery that they need to do, and it also seems that different products, different semiconductors that they are about to produce, they need quite different, I don't know, machine chains, right, in their factory. Okay, so as far as I understood, even now I think, and maybe also up to recently, a lot of this scheduling was actually done partially in a manual way, or sometimes even not in a not very organized way, to put it like that, which is a little bit surprising. And yeah, so Ramsha, Mohammed, and Martin, as part of their work, they try to address this and make it a little bit more organized and sometimes perhaps even provably optimal in a certain sense. And so essentially what you come up with in these scheduling problems there is, maybe you're familiar with job shop scheduling. This is what's going on here. In addition, they need some more flexibility, and I think this will be seen in a minute. So yes, it's formulated in answer set programming with difference constraints in part, in case you know what that is. And yeah, then there is the usual experiments and how it all worked out. So let's see what this is all about. I'll keep pressing the wrong button here. Okay, so right, so we have job shop scheduling. Okay, so essentially what you have is you have operations. These are on the left-hand side here. They can be done on several machines. Okay, sometimes they need a specific machine type here, okay? So like 011, I think should be performed on this top machine, right? This one is tied to this machine. The different machines, they can process several of these operations. Right, okay. In addition, you might have a couple of these machines at your disposal, okay, that you can then use. So a job is a collection of these basic operations. What that means is, okay, you have job number 1 here consists of 3 operations, job 2 also 3. In this case, all of the jobs consist of 3 operations, but I think this is just a coincidence. You can see that these operations can be, well, sometimes you need a specific machine for that, but there are some, like this one, that can be done on 2 different machines. So you have quite some variation of your input here. Of course, I will never learn this, okay. The task to be done here is actually a 2-step process. The first step is to assign a specific machine to each operation. So they call this assignment. And once you fix the assignment, you can try to schedule it. So meaning when do you do which operation? Okay. Okay, so this is one of the possible solutions for the scheduling here. You see each machine will do some of these operations. The operations, of course, also have a duration there, which wasn't shown so far, I think, or maybe in this table, the number was the duration. And you can see, okay, there are some dependencies, right? So in one job, okay, the second operation in the job has to wait for the completion of the first operation, and so forth, okay? I'm not sure, from this diagram, it seems that you always have to switch around machines, but this is not really the case. Yeah? It's just, I think, in this solution, by chance, okay, each operation for a specific job is moving to a different machine, but this is not necessarily so. Okay, right, so the other terminology, maybe you've heard about this, right? How long it takes in total for a given schedule is the make span. Okay, so far that's, heard that before. So what they use is a simulation data set. It's called SMT 2020. So it seems, I believe that SMT doesn't refer to SAT modular theory here, but this semiconductor manufacturing test bed or something like that. In there, you have, lots of instances for the scheduling problem. So, yeah. Right, so what you see here is you actually have several jobs to be done. These are grouped into lots, okay? In this case, these lots seem to be, wafers where you make a lot of semiconductors from. And, then you have groups of tools or machines, okay? And you have this, rather complicated looking flow between them. Yeah, here it says 300 to 600 steps. To be honest, I'm not completely sure whether that means whether you really have 300 stages going on here, but it might be. So that's a fairly complicated process. Down there, you also see, what these things are doing: implant, litho, dielectric. Yeah, there are a lot of steps to be done in general there. Okay, but okay, that I don't know much about semiconductors manufacturing, so okay, yeah. And you don't have to if you want to solve the scheduling problem, right? Because this stuff you all get as input. So yeah, the problem instances that they work with is seems to be characterized by high volume and low mix. Okay, and what they want to do is they want to optimize the make span, so the total duration of your schedule, for I think obvious reasons. So the other thing that comes up here is that there are two modifications, it seems, that are probably not as standard in the scheduling world, and this is maintenance, okay, which we have heard before, and machine setup. So very often, if you need to do something with the machine, a certain operation, okay, you first need to, I don't know, set it up somehow, calibrate it, maybe clean it, yeah, stuff like this. So yes, each instance there is defined as, you know, collection of facts, okay, that can later be used by the ASP system. So it's like a database, really. Okay, so you have these lots, okay, consisting of products. That's the terminology here. You have available tools, okay, with a group of tools and the number of the machine. I think they're all the same if they're in the same group. Then for the product, okay, you have these informations like, okay, which, sorry for the, it's called route for some reason. Which product is it for? This, the sequence number within, you know, the processing cycle for the product, I think. Which machine essentially it needs. If some setup is required, and if so, which one? And okay, the time it will take. So this setup here, it will refer to one of these, okay, things here, where you have, again, a group, the name, which tool group it refers to, what the setup is named, and how long it takes. And here, there is the PM stands for, I think, plant maintenance, where you need to perform some maintenance over time for similar reasons that Antzi has told us earlier, okay? So in this case, sometimes this can be fairly frequent that you need to do. And apparently the what they are given here is, okay, what type of maintenance, but more crucially, when you need to do that, okay? So the PM type tells you, okay, is it time triggered? So that after a specific time, you need to do maintenance, or whether it's you know, number of operations triggered. That, I think, seems to be the difference, okay? So some maintenance you need to do after a certain time, no matter how many jobs you did. Other maintenance you need to do after so many operations were done, okay? So there is this interval and how long the maintenance takes. I will never learn, okay. So here is a some specific examples for this. So yeah, okay. So machines, so first you see the tool group, there is implant 128, whatever that means. There are 2 machines available for that group, and so forth. Lot 1 has, you know, 2 products in this case, and the product number 3 needs 3 operations. 1, 2, 3 is the sequence of these operations, as you have seen earlier. And yeah, here it says the operation needs a machine of this group, needs a setup indicated in this way, and after the setup has been done, it still needs 7 time units to complete. Could also be that there is no setup to be done. In this case, you see a 0 here. Should rather point here, right? Okay. Setups. Okay, they are defined here. Okay, how long it takes. Nothing else really. For the maintenance, okay, you can see here, this can be different. Either you say lots, okay, after how many operations, I think, you need to do that. So between 1 and 2, so this is the interval, I think, and this is the duration, how long it will take. Or you have time, okay, then you say, okay, after 6 units of time, between 6 and 10 units of time, okay, you should do this plant maintenance, which takes 6. I'm not sure whether these numbers, I think it's just an example, right? Because it seems to be too frequent for practical purposes, right? Because you would have after 6, right? And you need this maintenance that takes almost as long as the interval. I'm not sure whether that's realistic. Okay, maybe you know better. So here is a program that they use in order to solve the problem. I should speed up, I think. Okay, the first is just technical, I think. It groups together, lots and products, okay, with the operations. So you have a definition of what an operation is that you need to schedule there. Then here they have 2 things that they can do. Either they have some kind of fixed assignment, then this rule becomes active, and it tells you has some fixed operations, right, where you have already assigned machines to operations, right? That's the idea. If fixed is not 1, okay, you will also do an assignment of operations to machines, okay? And down here, these are like, constraints. So if you have 2 operations on the same machine, okay, then you know that you have to order them in some way, right? Because you can't do both operations at the same time on the same machine. Okay. Right, so yeah, so here is, I'm not sure, I think it's supposed to be an example for counter-based maintenance. Like here, I think after 75 wafers that were processed, or 3 operations, you have the first maintenance event, or in this case, after 4 of these operations were done, you have the maintenance event here. Okay, and the second one there. Okay, so basically the way they do this is they select when you do the plant maintenance. Okay, so there's some bit of the program that you don't see here, and you make sure that okay, it is in the right interval, basically. So yeah. This machine setup, okay, yeah, I think it's fairly clear what you need to do there, right? So you can do some setup that applies to 2 operations, I think, if there is nothing in between. And some of the operations might not need any setup, so you can also just do this after the setup, right? So you can think of it of setting some parameters of the machine. And yeah, okay. So okay, so here's the bit that I didn't understand too well, to be honest with you. And this is where they also add some constraints in terms of difference logic. So maybe if some of you knows more about this, you can explain to me why this has to be written in this way. So I think what you do here, as far as I understand it, is you have these bits in the rule heads here that define constraints, okay? And they are like, I don't know, like linear constraints that say that, a given difference assigned to both of these terms, okay, has to be less than or equal to some value that you find on the right-hand side. And I think this is also why you have this funny looking writing where you have -t. You could say, okay, why don't you assign the numbers in a different way, but I think you need to have less than or equal here. That's you have to transform it in a way that it has this less than or equal format. Okay, so so to me this reads like the operation. Okay, the difference between the start and the occurrence of the operation. Okay, needs to be less than or equal to the setup time for this operation. Okay, so you need at least the setup time to happen before. Here, this says something about the difference between the occurrence of two operations, sorry, about one operation and the setup time in this case. And I think here you have something about when an operation should occur. And this is in relation to the make span, which is the last possible step. So it has to complete within the make span. So you could have encoded this in a different way, I think, but these different logic constraints make it more efficient. Right, and so I think for this example that you have seen, this would be an optimal schedule in this respect. So you see there are setup times there, operations that are scheduled, and 5 minutes, okay. Operations, and there is also some plant maintenance going on here. Okay, so I'm almost done. So they did some experiments using that SMT 2020 instances that they have. I think they tried it for 11 different settings that you see there. So what is this? M is the machines, okay, that you have. So in the simple case, you have 2 machines, 10 operators. Yeah, the columns are this one. The first column is about, you know, where the assignment for operations to machine has been pre-assigned. And in the second case, you also do the assignment from operations to machines on the fly, so to say, or you include it in the scheduling process. So what you see is that the red numbers, I think they are where you have make span, which is smaller than the other, than the than the respective other technique. So in here, okay, they are yield the same make span. Also the second line, but here, for instance, if you have a fixed assignment, okay, you have a longer make span that it found, and with flexible machine assignment, you can improve on this. So the timeout here, I think, refers to whether it was possible to find the optimum, which in this case wasn't possible. So these numbers should be, the best possible ones that they found. Yeah.
Why there's this slide at 30x4 where the second make span is greater?
I think it's because during the solving, it didn't find anything better, right? So where you have the fixed machine assignment, I'm not sure where this assignment came from, right? Maybe it was pre-assigned. I can't really tell you, but apparently this flexible machine assignment bit didn't find the assignment where you get such a short make span. This is my explanation for it, okay? So you see, there are some of these cases also here, for instance. Yeah, and you see, it takes quite a while, I think, to compute. I mean, to be fair, the time limit isn't that high, but yeah. Yeah, 600 seconds is not too much, right? So for scheduling, sometimes, I know in those factories, the techniques they use currently, they use all sorts of stuff, and sometimes it takes hours or even days to compute. So yeah, so that's their findings. So it seems they are happy with this because they could find some very good make spans with the various techniques. And so yeah, so this is the last slide about conclusions. So yeah, so they tried to use ASP with different logic in this industrial setting. So maybe what sets this apart from regular scheduling tasks is, these maintenance things that have to be planned in and the setup times. Task was optimizing the make span, and you had this choice of having a fixed machine assignment, possibly by experts or by somebody who does this frequently, or using a different algorithm, I'm not sure about that, or have it flexible and also being assigned by their system. Okay, so they tested this on the relatively small scale instances, because in the true factory, this will be much larger. Yeah, so there are some other features that they will need and will integrate in the future. And yes, it's available on this GitHub page. And I think that was it. Thank you for your attention. I hope I could explain a little bit what they do.
Thank you for the feedback. So, any questions? So, can I?
You can ask questions, but yeah, go on.
Okay. I think the flexible, 25 minutes. And the flexible job shop scheduling is somehow extension of classical job shop scheduling with maintenance time or setup time, I guess. And maybe the job shop scheduling program has been tackled from SAT and CSP and also ASP. It might be possible to encode this problem by using a constraint ASP. Might be more compact, I think, because in the constraint ASP we can use an integer variable, so maybe we can easily express the starting time and maybe diff constraint. I guess.
Yeah, I think this is actually.
Yeah, this is actually.
This is constraint.
Yeah.
ASP. Yeah.
Yeah.
So it gives this linear programming flavor here. Right?
Yeah.
Reduced linear programming. Yeah.
Yeah.
So yes, I'm sure Martin is aware of this.
Yeah.
Just a comment to that. I think these different constraints can be solved somehow using some shortest path algorithm or something like that. And therefore, it is very efficient formula is used here, but you cannot vary those differences. You cannot use them as variables.
Oh, yes. I mean, you mean, like these are terms and they will have an assigned numerical value, and what you're saying is that you can't maybe have it output.
And get the value of the difference to be used in further rules, but inside that.
Yes, just for checking. I understand. Yeah.
That part is it uses a SMT modulo theory, something like that, to calculate here. So, single the theory propagation for implementation, maybe.
I think so. Yes.
Yeah. I understand. Maybe that part is deal with the backend theory solver.
Yes, I think so. I believe. I'm not sure.
Yeah. Thank you.
So this is a modular theory bit.
Yeah,
I think.
yeah. The same technique used in the implementation of CleanCon. Yeah, I understand. Thank you. Any other questions? Okay.
If you have true questions, then please write to the authors.
Please ask Martin.
Yeah.
Okay. Thank you for the speaker.
Thank you for your patience.